Welcome back. We are almost through all of the basic material here. We've only got a couple of topics left. Let me see which ones we have. We have loops right now. We're going to have a couple of really quick special operations and then two quick lectures on arrays. And then we'll be all in on the Java basics and we get started with a brand new exciting topic. These last few should be pretty quick. Maybe the last one will be a little bit longer on arrays, but this one certainly should be familiar to everybody in this class. Loop control structures, right? So repeating elements, repeating commands in our code. So the learning goal here is being able to select and implement different types of loops depending on the scenario. So there are different types of loops that we have access to, and depending on the scenario, depending on what we need, we should be able to pick the best loop for the job. So, so as usual, there is something in my slides that makes no sense, which is that I forgot to change this header, but that's okay. We have three different types of loops that we kind of focus on. We have the for loop, the while loop, and the do while loop. However, we probably won't talk very much about the do while loop because we don't really use it. It's not that helpful. And anything we can do with a do while loop, we can do with a while loop. So it's just sort of another option, but not one that we typically find ourselves using. So all three of these can produce the same result. We can certainly solve any given problem with any of the three loops, but there are certain scenarios that make more sense depending on like the context, whether you should be using a for loop or a while loop. So let's start by looking at the for loop, which is the most common loop for sure, where we're going to go through iteratively for each element in a given condition statement here. So we can see here we have for int I equals 0, I less than 5, I plus plus. What this is actually saying is for a variable I, int I, that starts at 0, well, I is less than 5, do all this code, and then do I plus plus. So the first time that this loop runs, it runs while I equals 0. We can see right here in the picture, he's helping cut the cake. And then it says, I will help cut the cake. And then it comes back up to the top, and we do I plus plus. And now I will equal 1. So I equals 1, I plus plus, and this continues. So we get 0, 1, 2, 3, and 4. After 4, we come back up to the top of this loop, I plus plus, and we get 5. Now the question is 5 less than 5? And we know that 5 is not strictly less than 5. So as we can see, this individual is not actually reaching the knife. They did not get to help cut the cake because they are they're the breaking point for this loop, right? So we're going to do this loop iteratively until this condition is no longer true. Next one is a while loop. And the difference here between the while loop and the for loop is that a while loop only requires the Boolean expression inside the parentheses. So let's look one more time. We have a Boolean expression right here. But this requires more than just the Boolean expression. You also have to define the variable, well, set the starting point for the variable that you want to use and set the increment counter that you want to be using. So there has to be something that's sort of like moving along in this respect. With a while loop, we can set it just based on a Boolean scenario. So it's got less of a definitive end. Like a for loop, we can almost always say like finitely where the end of the for loop is going to be. In this case, it's going to run 5 times. Whereas with a while loop, because it is only based on a conditional, it's possible that like the variable that we're counting on in this conditional may change inside the while loop, whatever it might be. It may not be quite as obvious how many times the loop is going to run. Now here, of course, this is a very, very similar problem as the one that we saw to the for loop. So in this scenario, it looks exactly the same and it would run for the exact same number of times. A better example, though, would be imagining if you were using Scanner to get user input and you wanted the user to keep entering numbers that you would add together until they typed in the word quit. When they typed the word quit, you would exit the program. Now, we don't know how many numbers the user is going to want to enter before they type quit. it doesn't make sense to use a for loop because a for loop has to have a designated start and end to it. Whereas in a while loop, we can just say while the user doesn't enter the word quit, keep prompting them for more information. So we can see a scenario where a while loop just makes more sense. Really, it's all about asking ourselves in like plain English, in a storybook way, what are we trying to say? Are we trying to ask ourselves, are we trying to ask our program to continuously ask the user what numbers they want to enter until they enter a certain value? Well, if we want to keep doing it until a certain point, but it's not a definitive point, it's dependent on something else like a user, a while loop is pretty much always going to be our best bet. Now here we have our do while loop that we're going to look at really quickly, but again, like I said, not super helpful for us. And we can see that in this wonderful little image over here where we can see the Roadrunner, and Roadrunner says, while we're not at the edge, we can keep running. So the Roadrunner will stop because they've found the edge, so they stop. Whereas Coyote is using a do while loop, and we can see that a do while loop does do, run, and then checks the condition. So the main difference between a do while and a while loop is that a do while loop will execute the block first and then check the Boolean expression. So do while loops often only, or sorry, will always run at least one time. However, if you're already standing on the edge of a cliff, you really didn't want to run off the edge. So we can see a scenario where maybe this isn't going to be the most helpful and one we probably could have solved using a while loop alone. I find one of the best places to use do while loops is when we're doing user input, because typically we do want to ask the user for input at least once and then gauge what they say and go from there, as opposed to asking them first, then doing the while loop, and then having to re-ask inside the while loop. So then you end up with like two of the same prompts. A do while loop often makes sense in that scenario, but it's certainly not required. But like 9 out of 10 cases, you're going to want to just use a while loop, not a do while loop. Really quick note here. There are two kind of special keywords that we can use in Java when we have our loop statements, and they work in both for loops and while loops, or I guess in all for loops, while loops, and do while loops, but that doesn't mean we should use them. So a break statement immediately terminates the inner loop. So what we can see happening here is that our code is running in this while loop in the image, two statements run, and then we hit a break. And a break statement, literally written break semicolon, basically says bail out of this code block. So if we're in an if statement, it bails out of the if statement. If we're in a for loop, it bails out of the for loop. And pardon me, if we're in a while loop, it bails out of the while loop. So we can see it literally leaves the while loop and starts to execute the code outside of it. Some people like to use this instead of like making a Boolean, but it clutters our code. It makes it really difficult for markers to see what you're doing, especially in really long or big programs. So this is like purely for informational purposes. We are not going to be using break statements all willy-nilly in our loops in our code. The other statement here is continue, and continue immediately skips to the next iteration of the loop. So it's totally possible that for some reason you're doing some kind of conditional checks, and if you find a certain value, you don't need to keep running the rest of the loop. You can just go back up to the top and keep going from there. So there definitely are scenarios that I can think of where continue would be helpful, but again, we can just structure our code in a way where continue isn't needed. We can structure our like if else conditionals in a way that sort of means we don't need to use continues at all. And things like break and continue without really good variable names and really good commenting can just be confusing to look at. So if you look at our programming standards in this course, you cannot use these two terms. You can't use break and you can't use continue. You lose marks on your assignments if you do. However, they do exist. So it's important to know that they exist and that they're here, but for the purposes of this course, we're looking for better programming standards than just sort of throwing these in wherever. Okay, so that's all the material. 3 loops, don't use break, don't use continue, and I've got 3 practice questions here. One's for a for loop, one's for a while loop, one's for a do while loop. A reminder that really you could write any of these using any kind of loop. The for loop would be Questions 2 and 3 would be pretty tricky to do as a for loop, but they could be done. But if you are looking for more practice problems, you literally could do each of these in all 3 types of loops. It just may require additional logic to make it work the way that you are um, sort of hoping it will work. So I don't have solutions posted for these. However, if anybody is looking for any solutions or extra information for them, feel free to post in Piazza, and we'll have some kind of conversation there and move through them appropriately. And with that, we are finished on the loop code. Like I said, it's pretty short, just more like informational. Loops are not new for anybody at this point in our computer science class. We're going to do a couple of special operations, special methods, things like that. Talk about like the math library, and then we'll move on to arrays and be finished with this week's material.